Okay, ladies and gentlemen, you guys did a great job with surface area of a rectangular prism, and we had just started surface area of a triangular prism, and we'll keep practicing that on Monday also. But today we're going to add another layer. So one of the big differences between pyramids and prisms, which we talked about and we've been talking about since the beginning, is that prisms have lateral faces that are rectangles, and pyramids have lateral faces that are triangles. So in rectangles, we were often finding in rectangular prisms, we were finding parallel bases or parallel lateral faces that were congruent, and that made it easier. And one of the things that was tricky about triangles is even though the parallel bases were congruent, the lateral faces were not. Now, we're going to take a quick look at surface area of pyramids today. We're primarily going to work with triangular and square pyramids. And we're only going to be working on ones where all the lateral faces are congruent. Okay, there are obviously other examples and other possibilities. We're going to work with ones that are congruent. Okay. So there's a pretty picture in our book. We're on page 16 of the book. There's a pretty picture of a pyramid. Okay, so a pyramid is going to have one base, which we've talked about. Again, we talked about in the past. And so what we're going to do is we're going to find the surface area. So if we draw a net, right, a net is what happens when we unwrap the shape. If we draw a net, we will see that we have a square for our square pyramid, right, that's here. And then we have 4 congruent triangles. Now, what is the side length of this square? Well, let's take a look at the problem and find that information. Kara is making a model of the Pyramid of the Sun for a history project. The base is a square with a side length of 12 inches. Okay, 12 inches. Each triangular face has a height of 7 inches. Okay, so what is the surface area of Kara's model? So we have 5 pieces here, but we only have to make 2 major calculations. We've got our square, and then we've got 4 congruent triangles. And we've done work before where we've calculated multiple congruent triangles. Okay? So first we're going to find the area of the square. Since the side length is 12, that's 12 squared, which is 144 square inches. Okay? That's actually a square foot. And then area of a triangle. So the base of this triangle is, I bet you wrote down the number 12. One of the nice things about this is that the side length of the base and the base of the triangle, the base of each triangle in the pyramid is the same. And the height is, you guessed it, 7. So area is half times 12 times 7. Okay, and as I said before, half times 12 we should do first, right? Half times 12 we should do first. So that's 6 times 7, which is 42 square inches. Now that's one triangle. How many triangles are there? How many congruent triangles? Yep, you guessed it, and it says it right here. There are 4 congruent triangles. So we do 4 times 42, and then what do we add to it? Well, we add to it this number, right? The 144 for the base. So we've got a base of 144. We've got 4 42s. Okay. So that's, and again, I think my book's just a little funny. I would do then 144 plus, not times, plus 4 times 42 is 168. And then together we would have 2, carry the 1, 1, right? Because 4 plus 6 is 10. Carry the 1 is 11. And then we carry another 1 and we get 312 square inches. Okay? And surface area is very important for anything involving wrapping and covering. Okay? So we're going to take a look at one other example on page 616. And they have this whole strange thing about this lateral area. It's just, let's just add up the triangles. Just the triangles. Just the lateral triangles, because this is actually a triangular prism. Just lateral triangles. no base. So, I mean, it's not more complicated. You just have to read the question really carefully and see if it wants to just add the base or not add the base. Okay, so we've got Kwan. Kwan is making a tent in the shape of a triangular pyramid, right? So we know that a triangular pyramid has 4 triangles. We saw a triangular pyramid. We assembled a triangular pyramid. Actually, I think on page 599, way back on page 599, we assembled a triangular pyramid, right? And we saw that a triangular pyramid has 4 triangles. 1 of them is the base, and 3 of them are the lateral faces. There's also a similar net on 598 for a triangular pyramid. Okay, so it's the first thing that we're going to do is we're obviously going to make a net. Okay, so we got a nice little blank space here. Okay, and so let's just try to understand how we're going to make the net. The 3 sides of the tent are made of fabric and the bottom is left open. Okay, the faces have a height of 10 and a base of 6. So what this is implying is that they're all congruent triangles. Okay, so let's understand the base. Let's understand the base. This is going to be the left part that is left open. Well, what are its side lengths? What kind of triangle is it? Well, if you remember from before, and I also said before, we're only going to deal with equilateral ones. It's an equilateral triangle. Remember before in the previous problem, we said that the base of the triangle is the same as the side of the triangle. So that's 6, and that's 6, and that's 6. Now, each of those has a triangle coming off of it that has a height of 10. Okay, so we know how to find the area of a triangle, right? Oh, they want us to shade it in, right? So we could like color it in if we wanted. Just the part that we care about, because they said the bottom, there's no tent, there's no fabric on the bottom of the tent. We just need the lateral area. So that's just another thing that you have to have in a math problem is ask yourself, what part do we care about? Sort of like composite figures, right? This just looks just like a composite figure. So we have 3 congruent triangles. So what is the base times the height? Well, 6 is the base, 10 is the height. Half times 6 times 10, that's 3 times 10, that's 30. So each triangle has a surface area, or an area really, of 30 square feet. Now, how many triangles do I have? I have 3 triangles, right? So 3 times 30 is going to be 90 square feet. So the area of fabric that Kwan needs is 90 square feet. Okay, so let's just take a look at these last couple questions on the page. Make sure we understand them before we move on. Okay, so the difference between the surface area and the lateral area, and I'm just going to type this below, the surface area, well, the surface area includes all surfaces. Right, on all surfaces, includes lateral faces and bases, right? Everything is either a lateral face or a base in the kinds that we're seeing, prisms and pyramids, right? In the case of a pyramid, there's only one base. Now, if we are finding the lateral area, well, we're finding the area of just the lateral faces. And I know I have to fix that, not the base, or the bases if we're talking about a pyramid, a prism, I'm sorry, a prism. Okay. Okay, so explain how you could find the amount of fabric needed if Kwan decided to make a fabric base for the tent. The height of the triangular base is about 5 feet. Interesting. So 2 is, we just need to add the missing triangle, right? There's a missing triangle here, right? If we scroll up, it is a triangle with a base of 6, and now they've just told us a height of 5. We don't have to start again from the beginning. We can just do base times height times a half is 3 times 5, that's 15 square feet. And if it's the same, then we just add it to the original information. Technically, we shouldn't put that on the same line because it's not true to the sentence. And that's going to be 105 square feet. That doesn't look like a 5. I'll fix that. Okay, so one thing I want to just suggest, because I think some people have been coming into class and I think missing a fundamental concept from some of the videos. So if you have a question, I'm going to strongly recommend that you write a question on Classroom. Maybe even a really good question for a bonus homework point. But write a question on Classroom, right? Like, I don't understand the difference between a base and a lateral face, which I hope you do because we've been doing this a long time. Or I don't understand this, or I don't understand that. Be highly specific, but write those questions and I can answer them and your classmates can answer them and I'll know that we need to talk about them on Monday. Have a good weekend. Bye-bye.